So epsilon naught is the absolute permittivity of the vacuum. Now you see, if the same two charges are placed in some medium and whose permittivity is epsilon. So epsilon, this was of vacuum and this is the permittivity of medium. Then how we can write the force between the two charges when they are placed in the medium? So F is equal to 1 by 4 pi epsilon Q1 Q2 over R square. So epsilon here is the permittivity of the medium. Now you see how we can convert this epsilon into epsilon naught. So you see in this particular case, so this is the force when the two charges are placed in the medium. Now let us define one more term here, that is dielectric constant or relative permittivity. Dielectric constant or relative permittivity. Dielectric constant or relative permittivity is the ratio of the permittivity of the medium with the permittivity of the vacuum. So this can be written as epsilon over epsilon naught. So now you see how we, using this particular equation, how we can change this force. Let us write epsilon. So what we can write for this epsilon? Epsilon can be written as epsilon r into epsilon naught, epsilon r into epsilon naught. Or if a dielectric constant, I'm writing k, this can also be written as k times epsilon naught. So this force will become, I'm using this equation here, so this would become 1 by 4 pi epsilon naught epsilon r Q1 Q2 over R square. And now you see, this is what? This is the force between the two charges when they are placed in the vacuum. So we can write here, this is a force between the two charges when they are placed in vacuum divided by relative permittivity. Or we can simply write FV over K. So one very important relation again we are going to derive here, that force between the two charges when they are placed in the medium is equal to force between the two charges in vacuum divided by dielectric constant or relative permittivity of the medium. Also from this particular equation there is another formula for the relative permittivity of dielectric constant that can also be written as K or epsilon r. How we can write K? K would be written as Fv over Fn. So this is another formula for writing the value of the dielectric constant or relative permittivity. So this is all about the Coulomb's law, and you see from this particular formula, that is 1 by 4 pi epsilon naught Q1 Q2 over R square, we can simply find out the magnitude of the force when the two charges are placed at some distance. If we know the distance, what is the distance between the two, what are the charges on the two bodies, using the standard value of this constant K, we can find the magnitude of the force between the two charges. Now, you know that force is a vector quantity and only magnitude is not sufficient to write the this physical quantity. So we need to write the direction also. And for directions, we need to write this law in vector form. So let us write this law in vector form. We'll simply add the directions, that's all. Rest of the things will remain same. Only directions we are going to add here in order to write the force in the vector form. So let us write this Coulomb's law in vector form. So directions we are going to add here, nothing else we are going to do here. Now let us consider we are having two charges Q1, Q2, and they are separated by some distance R. Now because you see, because we need to have the directions here, we need to see what are the types of the two charges. Let first case we are going to consider both of the charges are positive charges. And we know that the positive charges, they will repel each other. So let us consider the force on charge 1 due to charge 2 is F12. This is just notation. You can use whatever notation you like. Force on 1 due to 2, and I want to write this in the vector form. So you see, this vector I have drawn here is representing the force on charge 1 due to charge 2. And you see, because this is positive, this positive charge is going to push this charge away from it. And similarly, if I'm writing the force on charge 2 because of charge 1, this would be in this direction because it is again being pushed by this charge. So I can write using the same notation, I can write force on charge 2 due to 1, and this is representing the along with the direction. So I'm putting vector sign here. For my convenience, let us consider one of the direction. Let us consider this direction is R12, and this direction I'm considering positive direction. And now let us write both of the forces in vector form. So if I'm writing F12 means this is the force on charge 1 due to charge 2. Rest of everything will remain same, K times Q1 Q2 over R square into. Now I want to write the direction. You see, what is this direction? This is opposite to this direction. So can I write R21 cap? Or I can write R12 with a negative sign because this is opposite to this direction which I have considered positive. Or in other words, I can write this is from 2 to 1 means it is this direction I am considering. So cap means here this is simply a unit vector which is telling us the direction of this particular force. And let us write second force F21 K Q1 Q2 over R square, and direction is what? This is in the direction of this particular R12. So I am simply writing this direction along with this cap R12. So this force is in direction of R12 and this force is opposite to R12. So that is why I have written 2, 1 here. And now you see, for convenience, if I am using the same symbol here also, I can use 2, 1 here. And I can use 1, 2 here. This is only magnitude. It is not going to be affected here. I'm just putting this a distance. I'm taking from 1 to 2 or 2 to 1. Otherwise, it's simply magnitude. It is not going to affect it. Just to write in vector form, I am using these words here. Now, from these two equations, what we can conclude, both of the forces are equal in magnitude. Magnitude, there is no difference. Difference is only in the directions. You can see here, this is R21 and this is R12. So what we can say, R12 is in this direction from left to right and R21 is from right to left. Only opposites means these two forces are opposite to each other, but the magnitudes are same. So what we can write here, F12 is equal to F21 because both of the forces are opposite, so I am putting this minus sign. And you see, both of these two forces are equal in magnitude and opposite in direction as per Newton's third law of motion. Two objects are applying force, equal and opposite forces on each other. Similarly, if you want to see the direction of the forces on two negative charges, for example, I am having two negative charges. I am using the same diagram. Let us consider if Q1 and Q2. Q1 and Q2 both are negative. The same scenario would be there. You can see here Q1 and Q2, both of them again slight charges, they will repel each other. Q2 will repel Q1 in this direction and Q1 will repel Q2 in that direction. Same expression you will get for these two forces also. Now let us consider if we have two unlike charges, one is positive, one is negative. So you can note down this is the expression for the two forces. We will use it later also. And if two charges are unlike charges, then consider Q1 is negative and Q2 is positive. They are separated by distance r, and again r12, this direction I'm taking positive, and now you see both of the two charges, they have opposite signs, so they will attract each other. Q2 will attract this charge towards itself. So what is the direction of the force on this particular charge? That would be in this direction. It is trying to move towards Q2. So here force on 1 due to 2 is in this direction. It is being attracted towards Q2. And similarly, this charge would be attracted towards this negative charge. This is negative. It is trying to pull it towards itself. So similarly here we can write force on charge Q2 due to 1 is in this direction. Again, simply we can write the expressions of both of these two forces using the directions. So let us write down what is F12. F12 you can see here, now it is in the direction pressed, magnitude will remain same. So F12 is what? K times Q1 Q2 over R, we will write it later, R square. And what is the direction here? You see this direction and this direction which we are considering positive, they are same. So I am writing this is R12 cap. Here also I can write R12. So this is the force in terms of vector formation, vector form. And similarly, force on 2 due to 1 is what? This is K Q1 Q2 over R. Now, what is the direction of this force? This is opposite to this direction R12. So I can write here R21 cap. And here also you can write R21. And again you can see rest everything is same, only the magnitude directions are opposite. So again we can write F12 is equal and opposite to F21. So whatever the case we are considering, whether both of the charges are positive, both of them they are negative, and even if they are positive and negative, this law is valid. And we can write as per the directions you can consider this direction also positive, opposite also you can consider positive. So it is not going to affect it, but your diagram and your expressions, they must match with each other. Whatever you're showing here, that should reflect in your expressions also. And now in vector form, this is cap only. If you want to write in the vector form, how we can write, how we can change the expression? So let us consider, I'm going to use one of the expression here. In vector formation, how we can write? You see, any unit vector, for example, I'm having a vector A. Vector A is the vector into magnitude of the vector into magnitude of mod, or simply I'm writing A here. So this, how can I write this? A cap, if I want to convert this cap into a vector, I have to multiply it with the magnitude. So similarly, I don't want to write this expression in terms of cap, I want to write this expression in terms of a vector. I want to convert this into a vector. So I have to multiply this with its magnitude. So if I'm multiplying here, I have to multiply here also. So let us write this expression. K times Q1 Q2 R12 square R12 cap into R12. You see, I am multiplying here with R12. I have to multiply here also, so that the expression should not be changed. So now let us write this as K Q1 Q2 over R12 Q. And you see what this would become. This is magnitude and direction. This would become a vector, that is R12 vector. So this is the force between the two charges in the vector form. So from here you can tell the direction also, direction of force on a particular charge because of the other charge. So this is all about today's lecture. Thank you.